students, let us try to understand some basic terms used in NLPP. Objective function. Consider an objective function z of x where x represents the input variable. For example, z of x is equal to x square plus 3x minus 4 is a quadratic objective function. Means your highest degree of the variable is 2 here. So this is known as quadratic objective function. Non-linear function. Any function that is not straight line is non-linear. For example, sin x is a non-linear function, e raised to x is a non-linear function. So any function which is not straight line is non-linear. Then we will see the term optimization. In unconstrained optimization, we aim to find the minimum or maximum value of the objective function. Optimization means finding minimum or maximum value of the objective function without any restrictions. For example, here z of x is equal to x square minus 4x plus 5. We want to find the minimum or maximum value of f of z by varying x. So here the graph of x square minus 4x plus 5 is like this. Here x will vary in this direction and the function is represented by a parabola here. Then we will learn about local minimum and maximum. For the function x square minus 4x plus 5, here the point x is equal to 2 is a local minimum because the function is lower around x is equal to 2 and in any nearby point. Similarly, x is equal to 2, if we put x is equal to 2 here, z of x is equal to 1, which is a local minimum value. If you see here, x is equal to 2 is a point here. For x is equal to 2, this value of z of x is equal to 1. So this is a local minima. If you consider the function f of z of x is equal to x cube minus 3x, and if you plot the graph of this x cube minus 3x, so these are the minima. Okay, minima and maxima here. So there may be more than one minima and maxima. We are going to call it as local minima, and sometimes we may call it as a global maxima or global minima if exist. Global minimum or maximum. In the example which we have discussed, x square minus 4x plus 5, there is no global minimum because if you increase the value of x, okay, then the parabola, it goes, it is going open upwards and it goes to infinity, positive and negative infinity. So for this function, there does not exist, global minima. Then we have to understand what is meant by gradient and derivative also here. Suppose whatever the function they have given, z of x is equal to x square. Suppose this is a function, its derivative is 2x. So we know the formula for finding the derivative of the function. Gradient. The gradient is a vector that points the direction of the greatest rate of increase of a function. So for multivariable function, suppose x and y, these are the two independent variables. Sometimes we denote it by x1, x2 also. Then the gradient, that it will be, we have to take partial derivative. That is dou z by dou x, comma dou z by dou y, or with respect to x1 and x2 also. Critical point. The function, suppose this is the function, The critical point is where the derivative is zero. So if you differentiate this function, then if you differentiate the above function, then we know that z dash of x, which is the derivative of x square, is 2x minus derivative of 4x is 4. And if you equate this z dash of x equal to 0, that is 2x minus 4 equal to 0, and if you simplify here you will get x is equal to 2. So x is equal to 2 is a critical point here. Let us understand what is meant by convexity. A function is convex if the line segment between any two points on its graph lies above the graph itself. For example, f of z of x is equal to x square. If you see, this is the graph of the function z of x is equal to x square, and if you join any two points on the graph, then the line segment between any two points, okay, uh, any two points on its graph lies above the graph. Okay, so this line lies above the graph. So we can say that this is a convexity concept. Let us understand what is meant by concavity complex. A function is concave if the line segment between any two points on its graph lies below the graph itself. For example, z of x is equal to minus x square, and if you join any two points on this graph, okay, so this line segment lies below the graph. So we can say that this is the concavity concept. So in this way, we have seen some important concepts of NLPP, objective function, then it's a gradient, then concavity and convexity. Thank you.